In this video, I will explain the concepts of big data and Hadoop and how they are applied in Industrial Internet of Things or Industrial IoT. Industrial IoT refers to the use of connected sensors, machines, controllers, and industrial equipment that continuously collect and exchange data over networks. Modern factories, power plants, oil refineries, and manufacturing facilities deploy thousands of sensors to monitor temperature, pressure, vibration, energy consumption, machine status, and production quality. The challenge is that these devices generate enormous amounts of data every second. Traditional databases often struggle to handle such large and continuously growing data sets. This is where big data comes into the picture. Big data refers to data sets that are too large, too fast, or too complex for conventional data processing systems. Big data is commonly characterized by the five V's. The first V is volume, which represents the massive amount of data generated by industrial sensors and machines. The second V is velocity, which refers to the speed at which data is produced and must be processed. The third V is variety, meaning that data can come in multiple formats such as sensor readings, machine logs, images, videos, and maintenance records. The fourth V is veracity, which focuses on data accuracy and reliability. The fifth V is value, which represents the useful insights extracted from the data to improve business operations. In industrial IoT environments, all five characteristics are present. A smart factory may generate terabytes of data daily from production lines, robots, and monitoring systems. To store and process this massive volume of data efficiently, organizations use Hadoop. Hadoop is an open source framework designed for distributed storage and distributed processing of large data sets across clusters of computers. Instead of storing all data on a single powerful machine, Hadoop distributes data across multiple computers, making the system scalable, reliable, and cost effective. The Hadoop ecosystem mainly consists of three core components. The first component is HDFS, or Hadoop Distributed File System. HDFS stores data across multiple nodes in a cluster. It also creates replicas of data blocks to ensure fault tolerance. If one node fails, the data remains available from another node. The second component is MapReduce. MapReduce is a programming model used to process large datasets in parallel. The map phase divides the task into smaller subtasks, while the reduce phase combines the results to produce the final output. The third component is YARN, which stands for Yet Another Resource Negotiator. YARN manages cluster resources and schedules processing tasks efficiently across different nodes. Now let's see how Hadoop supports industrial IoT applications. Consider a manufacturing plant equipped with vibration sensors installed on motors and machines. These sensors continuously send data about machine health. Hadoop can store years of sensor data in HDFS. Using distributed processing, engineers can analyze patterns and identify signs of equipment failure before breakdowns occur. This approach is known as predictive maintenance. Instead of performing maintenance on a fixed schedule, maintenance activities are performed only when data indicates a potential issue. This reduces downtime, lowers maintenance costs, and improves equipment reliability. Another application is quality control. Industrial IoT systems collect data from production lines in real time. Hadoop can process this data and identify trends related to product defects. Manufacturers can then adjust process parameters to improve product quality. Energy management is another important use case. Sensors monitor electricity consumption across machines and facilities. By analyzing large data sets using Hadoop, organizations can identify inefficient equipment and optimize energy usage, resulting in significant cost savings. Hadoop also plays a key role in Industry 4.0, where intelligent factories use data-driven decision-making. By combining industrial IoT devices with big data analytics, organizations gain deeper insights into operations, improve productivity, and enhance overall business performance. However, Hadoop is not without challenges. Industrial IoT systems often require real time analytics, while traditional Hadoop MapReduce is more suitable for batch processing. To address this limitation, Hadoop is often integrated with technologies such as Apache Spark, Kafka, and real time analytics platforms. In summary, industrial IoT generates massive amounts of data that exhibit the characteristics of big data. Hadoop provides a scalable and fault tolerant framework for storing and processing these large datasets. Through applications such as predictive maintenance, quality control, energy optimization, and smart manufacturing, Hadoop helps industries transform raw data into valuable